Today we are going to discuss the comparison. Today we are going to discuss the comparison between the bases. Like, I mean to say, which one is a stronger base and which one is weaker base. So remember, I told you um, there are two groups. We have also discussed this in arenes. I told you there are two groups. Number one is electron donating group. Number two is electron withdrawing group. Right? Electron donating group and electron withdrawing group. So if electron donating group is attached to the nitrogen in amines, so remember it becomes a stronger base. It becomes a stronger base. And if there is any electron withdrawing group attached to the nitrogen, any electron withdrawing group is attached to the nitrogen, so I would say that the compound becomes weaker base. Like amine would become weaker base. So it totally depends on that who is attached with the nitrogen atom. Okay. So we have done the comparison between the normal ammonia with the amine. I told you that amines are more basic as compared to ammonia. Why this is so? Why this is so? Because in amines, R is attached. R means alkyl group is attached. When alkyl group is attached to the nitrogen, so this is electron donating group. The nature of this R is to donate electron. If they would be donating electron to the nitrogen, nitrogen is already having a lone pair of electron. So this lone pair is repelled by the R group. So means that this lone pair of electron on the nitrogen is more available, isn't it? It would be more available. So it would be more available, it would become a stronger base. So what I did, when it gives electron to the nitrogen, already it's having a lone pair of electron, there would be repulsion, resulting amines gives electron pair more easily. So therefore amine is a stronger base than ammonia. Amine is a stronger base than ammonia. Okay. So then we have discussed this would be chlorine as chlorine is attached to the nitrogen directly. Okay. So we have two types of compounds. Number one is ethylamine. Number two is this. When chlorine is attached. So chlorine is electron withdrawing group. So the lone pair is not available because chlorine would be taking this lone pair of electrons. So it would be less available. When it would be less available, it becomes weaker base. When it would be less available, so it would become weaker base. Remember. Okay. And also we have this one. Let's say this is called phenylamine. This is called phenylamine. Like NH2 is attached on the benzene ring versus CH3NH2 like methylamine. So what we have to write, which one is a stronger base and which one is weaker base. Okay. So since we know that, again I would say that this ring, this ring, arene ring is electron withdrawing. Arene ring is electron withdrawing group. So this lone pair of electron which is present on the nitrogen would be delocalized into the ring and the lone pair is not available. So the lone pair is not available to the coming compound. So I would say that it is a weaker base. It is a weaker base. The same goes with the metals. When the metal can give its electron more easily, so the metal would be more reactive. And when the metal doesn't lose its electron easily, so the metal would be less reactive. It's all about how easy the metal is going to lose its electron. If it would be losing its electron easily, If it would be losing its electron easily, so means that it would be more reactive metal. And if it's not, so it would be less reactive metal. Simple. So we can say the ring is electron withdrawing. So the ring is going to take away the lone pair of electron from the nitrogen, and it's less available. So I would say that this would be weaker base, and as compared to this one, this lone pair is more available. If you are saying why it's more available, so I would say that the CH3 group is attached. That is an electron donating group. So electron donating group is going to donate electron to the NH2, and already there is a lone pair of electron on the nitrogen atom. There would be repulsion between electron and electron. So this lone pair is more available. When this lone pair is more available, so I would say that this is going to be a stronger base than phenylamine. Okay, so you must know which is stronger base and which is weaker base. Okay, and then we can classify we can classify amines. We have three types of amines in total. So amines type of type of amines. So we have three types of amines. Number one is primary amine. It's the same as we have discussed with alcohols. Remember, primary alcohol, secondary alcohol, tertiary alcohol. So the same goes with this. So number one, we have primary amine. Okay. And then we have secondary amine. And then we have tertiary amine. Primary amine, secondary amine, and then we have tertiary amine. So what is primary amine? It would be R, then N, then H, then H. And what is secondary amine? When there are two R groups. And what is tertiary amine? When there are three R groups. The electron pair is the same, right? There is no change in the lone pair of electron, right? There is no any lone pair of like the position of the lone pair would remain same. The thing is, if there is one R group like alkyl group, so it's going to be primary. When there are two, it's going to be secondary. When there are three, it's going to be tertiary amine. So here are some examples of primary amine, that is CH3NH2. And then we have ethylamine, that is CH3CH2NH2. You can identify by looking at NH2, like two hydrogens with the nitrogen. It's going to be primary amine. And if we talk about the secondary amine, so it would be CH3 taken twice with the nitrogen, and there is only one hydrogen. Of course, it's going to be secondary amine. How can we identify? So we can see NH. It's not NH2, it's NH. Only one hydrogen with the nitrogen. And for the tertiary amine, I can say trimethyl, CH3 taken 3 and then with nitrogen. There is no any hydrogen in it. There is no any hydrogen which is attached with the nitrogen. So I would say that it's going to be, I would say that it's going to be what? It's going to be primary amine. Okay. So whenever in the question, examiner would be asking after looking at after giving you the structure of any of the compound, any of the molecule. So you have to identify at that time after looking at the number of hydrogen atoms. Okay. So remember, uh, what is the difference between primary, secondary, and tertiary on the basis of their basicity? Like I mean to say which one is a stronger base and which one is a weaker base. So of course, I told you we are supposed to decide the strength of base after looking at like how easy they are going to lose their electron pair. If they would be losing electron pair more easily, it's going to be stronger base. And if they are not going to lose electron pair more easily, it's going to be a weaker base. It's all about how easily they are going to donate their lone pair of electron. Okay, so uh, I would say primary amine is also called 1 degree amine, 2 degree amine, and then 3 degree amine. So remember, 3 degree amine is more basic than 2 degree amine, and then 2 degree amine is more basic than the 1 degree amine. Simple. You know why? You know why? Let me explain one molecule to make it easier. Let's say this is nitrogen having a lone pair of electron. This is going to be CH3. This is going to be CH3. This is going to be CH3. And we know that CH3 is electron donating group. They are going to donate electron to the nitrogen. So the nitrogen is already having a lone pair of electron. So this lone pair is repelled by the three methyl groups. Okay, so means that it's more available. It's more available. It can lose its lone pair more easily, can donate more easily, can donate more easily, can donate more easily. So it would be a stronger base. Simple is that it would be weaker base. It's very easy, right? It's very easy to have an idea which is stronger and which is weaker, right? Okay. And then are they soluble in water or not? Are they soluble in water or not? So remember, we are going to discuss the physical properties of amines. So remember, they are miscible with water. You know, miscible means the superlative degree of the solubility. When something is having a good solubility in water, we use the word miscible in water. So it has the good solubility with water, good solubility in water. Why? Why they are having good solubility in water? Remember, because they are going to form hydrogen bond with water. That's the reason. So let's talk about the physical properties of amine. Okay, physical of amine. If we talk about the physical properties of amine, remember, boiling point is related to the intermolecular force of attraction. So CH3, then CH2, then CH2, then CH2, then NH2. This is non-polar part. This is your non-polar part. This is the polar part. If we have a non-polar part, so there is a London force. And if there is a polar part, so then we have a permanent dipole. Especially, especially this is NH2, so it's going to make hydrogen bond as well, . So I can't say that they are having high melting and boiling point. I can't say that they are having low melting and boiling point. Why? Because it depends on the, you know, uh, it depends on the strength of, it depends on the strength of intermolecular force of attraction. Okay. So as the number of carbon increases, as the number of carbon increases, so the IMF increases, so the boiling point increases, and vice versa for the decrease in carbon atom, isn't it? Vice versa for the decrease in carbon atoms. Okay, so depends. And also, what about the density? And also one thing is more. Let's say I have CH3, CH2, 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 NH2 versus CH3, then CH2, then I have CH3, and then I have CH2, then NH2. Yeah, then what we are supposed to do, I would say it is going to be higher boiling point and it's going to have low boiling point. The thing is why? What's the reason? So more surface area, more area. And for this one, I would say less surface area. For this one, I would say less surface area. Okay, more surface area or less surface area. Simple. More surface area and less surface area. So simple is that. Okay. Or so it depends on the two factors. Number one is the number of electron, like I mean to say the number of atoms. And the second thing is to have a surface area. More surface area, more IMF, less surface area, less IMF, and accordingly we can compare it with the melting and boiling point. Okay. And what about the solubility? So I would say they are miscible in water. They are miscible in water. Remember, amines are miscible with water. They are having a good solubility. As they form hydrogen bond with water, hydrogen bond with water, you can see this is CH3 and NH2, pair of electron. This is going to be the water molecule, and this is going to be the hydrogen bond. It has a pair of electron, right? And it's going to be partial negative. It's going to be partial positive. Nitrogen is partial negative. Hydrogen of water is partial positive. So that's called hydrogen bond. This is one of the reason that they are having good solubility in water. Okay. And also, I would say that whenever you are going to dissolve amine in water, basically solubility means you are going to dissolve amine in water. So what would be like what would happen if we are going to dissolve amine in water, right? So you know, alkaline solution is formed. Alkaline solution is formed. Let me tell you. Let me tell you what happens. What happens when they are dissolved in water. So when amines dissolves in water, remember alkaline solution is formed. You can see I have this is tertiary amine. Okay, I'm going to dissolve in water. This is partial positive, this is partial negative. We know that. And we have also discussed in the previous units when we were discussing the dative covalent bond. Okay, so this lone pair would give, like the nitrogen would give its lone pair to this hydrogen, right? And they would be forming a dative covalent bond in this manner, like that, like that. Okay. Due to this, there is a positive charge on this one. There is a positive charge. Along with that, there would be OH negative ion. So due to the formation of this OH negative ion, due to the formation of this negative ion, okay, due to the formation of this negative OH negative ion, that's why I was saying alkaline solution is formed. Okay. So let me tell you one more important thing regarding hydrogen bonding. That is, I can say, a lot of people having confusion in this one because uh, in MCQ there is a question. In MCQ there is a question they have asked that which structure best represents hydrogen bond between methylamine and water. I'm going to write down all the possibilities. You can see this and you can tell me what's the best representation, right? So this is the first representation that they have given. I'm not sharing a picture. I have to write so that it would be like penetrating in your mind. The first structure is this one. This is the first structure, right? And this is hydrogen bond. Okay. Let me write down another possibility. In the second way, they have done like that. They have done like that. In this way, in the third structure, they did like that. It's very interesting. It's very interesting. It's a good question. Okay. So in the third one, this is like that. I can copy this to save the time like that. Okay. And that's the hydrogen bond. In the third way, they gave like that. In the third way, they gave like that. Now we have to decide which is correct. Yep. So what is the best way? What is the best way to describe this structure? What is best way to show hydrogen bond? You know, the answer is this. This is the best way to represent hydrogen bond with water. First of all, the bond should start from the lone pair of electron, remember? Should start from the lone pair of electron because we know that this is partial positive and partial negative oxygen. They are completely wrong. They are completely wrong way to represent hydrogen bond because whenever hydrogen is attached to the carbon atom, whenever hydrogen is attached to the carbon atom, so this hydrogen can never be partial positive. This is very interesting to know. You know why? Because hydrogen is partial positive when it is attached with the electronegative element. When hydrogen is attached with the electronegative atom, then it's going to be partial positive, otherwise not. Otherwise, a big no. Let's say when hydrogen is attached with the nitrogen, it's going to be partial positive. Why? Because nitrogen is more electronegative. It's taking away electron towards itself and making this hydrogen positive. But carbon is not electronegative. Carbon is not taking away electron from the hydrogen. It's not going to make that carbon, that hydrogen more partial positive. So this is not possible. We have to decide between A and B. Okay. So B is correct. Like this one is correct. Okay. Let me say, let me say this is A and then this is B and then this is C and then this is D. So B is the correct way to represent hydrogen bond between the amine and water. Okay, you must know these things, right? Okay. Then uh, afterwards, I can say that chemical properties of amines, chemical behavior, chemical reactions of amine. So number one, we would start from we would start from halogenation. Halogenation, like I mean to say, we have haloalkanes, we have haloalkanes, and it's going to react with ammonia. By the way, we are going to prepare amines. We are going to prepare amines. So ammonia, ammonia with haloalkane. What would happen when they would react with each other? What would happen when they react with each other? So I have CH3, CH2, then CH2, then bromine. And this is reacting with ammonia. As a result of this, product is formed, like amine is formed, that is propylamine, and this would be the byproduct. This would be the byproduct. Okay. Also, what would be the reagent and condition for this reaction? Reagent and condition. So I'm taking ammonia in ethanol. Ammonia in ethanol plus heat under reflux. Heat under reflux. Okay. Why? Why I am taking ammonia in ethanol? Why not aqueous? If I would be taking ammonia aqueous, if I would be taking ammonia aqueous, so remember, as a result of this, alcohol would be formed. I don't want to have an alcohol. I want to form amine. I want to form amine. Remember. So, to prevent the formation of alcohol, we are not supposed to give any environment in which there is OH. So, of course, OH comes from water. So, I'm not supposed to take ammonia aqueous. Okay, so I'm not supposed to take ammonia aqueous. To avoid this reaction, we have to take ammonia in ethanol, and this reaction is called nucleophilic. Nucleophilic substitution reaction. So the type of reaction is a nucleophilic substitution reaction. Why I'm saying that this is going to be nucleophilic? Because negative substance is reacting with the negative one. That's why it's a nucleophilic substitution reaction. Okay, it's a nucleophilic substitution reaction. Right. Okay. Then what's the mechanism? Then what's the mechanism? Mechanism. In mechanism, what we do, we have, let's say, Br, hydrogen, this is partial negative, this is partial positive. Okay, so we have an ammonia that has a lone pair of electron, isn't it? It's going to attack on this positive carbon atom. As a result of this, the bromine has to be removed. The bromine has to be removed from here because you know the valency of carbon cannot be more than 4. Carbon cannot form more than 4 bonds. As a result of this, you can see that CH3, then CH2, then C, then the nitrogen is attached over there. And ultimately, these two hydrogens are the same. Of course, this nitrogen would be positive in nature. Why? Because nitrogen forms four bonds. When there is three bond with the nitrogen atom, so it's going to be neutral. But when there is four bonds, it's going to be positive. How can I balance it? So this hydrogen will give its electron to this nitrogen to make more stable, product, and the rest of the structure would be CH3, then CH2, then C, then NH2, and then be the same hydrogen atoms, and H positive is removed, and that would be Br minus. They would be reacting with each other to form HBr. That's called the mechanism, how the product is formed. So you know how I did the curly arrows, how I wrote the partial charges, how I have shown the lone pair of electron. So you have to show these three things. Number one is the curly arrow, number two is the lone pair of electron, number three is the partial charges. Then you would be getting the marks, and that's it.